Hi, and welcome to the screencast on Azure Machine Learning. My name is Tim Jacobs, and I would like to do a follow-up to the cloud chat on machine learning of last month. And we mentioned a few times that Amazon is geared more towards a developer that quickly wants to add some form of intelligence to your applications, whereas Azure Machine Learning, which is going to be today's topic, goes much further and focuses more on the data scientist. Now, the goal of this screencast is to demonstrate this by using the same example that we used in the Amazon case. For the detailed discussion on what machine learning is and what use cases exist, I will have to refer you back to our earlier recorded cloud chat because we will delve right into the details in a few moments. So we start again with our set of mushroom data. And again, the goal is to predict whether, based on the visual characteristics of a mushroom, whether it is safe to eat or not. So let's have a look at the Azure Portal. I've already logged into the Azure Portal here, and you can see, well, amongst the many services that Azure offers, there is one called Machine Learning. You will see that once you've created a machine learning workspace, you have to edit it in the Machine Learning Studio, which at the time of this recording is still a separate product. Now, the concept or the main concept in Azure Machine Learning's Web Studio is that of experiments, which is basically where you're going to create the intelligence that analyzes the data. As always, everything starts with data, and I've already taken the liberty to upload the data set that we also used in Amazon. Which is also interesting to know is that there are plenty of samples available in the machine learning interface. So if you don't have your own data set available right away, you can start experimenting, for example, with credit card data, etc., etc. Everything starts with an experiment. An experiment is basically where you're going to create the workflow that will make your predictions. And it is interesting that Microsoft is calling this experiments because, well, in fact, it is pretty close to what machine learning and data science is about, because it is really researching, trying to find a prediction, testing it a bit, tuning it again. So the concept of experiment is actually a good label that covers the work that needs to be done. So in this case, let's start by creating a new experiment. Now we're going to start with a blank experiment here. And you see immediately that the editor for the workflow opens. First of all, you get an example flow of the components that you need. And you see that this is a visual way of creating a workflow. So here on the left-hand side, we have several tools available, such as the models that we can build. So in this case, the classification models. We can do data transformations like filtering or splitting the data sets, which is something that we'll do in a few moments. Well, if you want to add your own Python scripts, R scripts, it's all possible. So there are quite some tools available in readily made modules that you can group together to create, let's say, a flow which will provide you with predictions and hence will provide you with some intelligence in your application. Now, in this case, we will start with our predefined data set, which is our mushroom data set. And we're going to drag and drop it here at the start. During the entire creation process, you can always inspect what is going on. So for example, if we right click on this endpoint, we can press visualize, and then we can inspect the data that we have here. So you will recognize here the columns that we also had in the Excel file, but things like the distribution that is available, what values are possible is also visualized here. The first step that we're going to do is split our data in two parts. Now, again, remember that one part of the data we will use to train a model. So correlations between the input variables and what we have to predict are detected in the training data set. And then we will test how good the actual model scores by feeding it with data that it has not been trained with. And that's the second part of this split. So this is a very visual process. So it's really dragging and dropping to connect the data, in this case with the input of the split. And you see that on the right hand side, you can define some values with respect to the splitting. Here we will specify what fraction, what percentage is put in the first output node. A typical split is 70% of the data that's being used for training the model and 30% for evaluating the model afterwards. So in this case, the appropriate fraction to enter would be 0.7 to have 70% of the data used for training. You see here that you have quite some control, first of all, how the splitting is done, but also whether the data should be randomized. Now, this is interesting because something simple like randomizing your input data is not available in Amazon. Now, I'm going to deliberately disable randomization here because this data set is specifically manufactured for machine learning purposes. By not randomizing it, we will introduce some bias, which will give us some, let's say, more tricks to play with. And it's also a bit more representative for real data because that's hardly ever perfect. Now, after splitting the data, we'll feed the first 70% to a model that we're going to train. This is again a component that we need in our workflow. Here it is located under the machine learning train category. And what we need to do is we just want to train a specific model. So we're going to feed this data here to the dataset entry point for the model. This is a generic placeholder because one other input that is taken by the train model block in this workflow is the type of model that needs to be trained. And this is really where Azure Machine Learning sticks out, because you can see already visually that there are a lot of possible models that can be used in the Azure Machine Learning Studio. So that also means that you need to have a very basic understanding of what these models mean and what type of output that they generate and what situations they are good for. Now, in this case, we are interested in predicting a binary value. Is the mushroom edible, yes or no? So we're looking here at one of the two classification models that we can use. We will use the logistic regression because this is very likely what Amazon is also using in the background. So again, you drag it, we connect it here in our train model case. Now, the only thing that I still have to do is to define the target attribute, which is the attribute or the characteristic that we want to make a prediction about. So we will launch the column selector here, and we're going to make a prediction for the safe column, which contains either 0 or 1, 1 being the mushroom is safe to eat. Remember that for the data, we had 70% of the data that we used to train a model. The other 30% of the data we will use to score the model and see how well it performs against data that it has not been trained for. Now, this is again one of the items that we can select for the workflow under the machine learning category. So here we drag and drop again the score model item, and you see that it takes as one input the 30% of new data, and the other input is the trained model that we want to check with new data to see how well it performs. And the output here is a scored dataset, which basically provides us with insights on how well this model performs. In order to visualize the result of the scoring into meaningful parameters, you have to feed it to the evaluate model item. Okay, so let's run it, and you will see immediately that Azure Machine Learning is very fast in executing the workflow that you've created. So let's press run here. And after a while, it will start running. So the input dataset has been performed. Okay, at the moment, it's still being queued. The data has been split. The model has been selected. Now it is training the model, which is already done. Remember, this took over 10 minutes at Amazon. It's creating the scoring of the model now with respect to the 30% of remaining data. This also goes very fast, as you see. It takes something like 20 seconds. And then finally, it will, well, let's say, put all these results of this scoring into some nice parameters, which has been done now. So how do you see this? Right click at the end node, and then you can press the visualize button, which in this case will show us what the result of the evaluated model is. Now, this gives us some statements about the accuracy of the model. You can see here that the accuracy is about 67%. In real life situations, well, these are actually the type of accuracies that you can expect. The next step is, of course, that we use this workflow in order to make real-time predictions. For example, from a mobile application, publishing such a workflow is done as a web service. Now, let's jump to Eclipse, where I've written a small Python script. Here we connect to the Azure Machine Learning web service. We provide the API key which is used for authenticating against this web server. You just provide all the data that you want. How does it work? Again, it's very simple. We just take the data, we put it into JSON format, we post it to the URL, and the result that we get back is a prediction on whether the mushroom will be safe to eat or not. So let me quickly run this, and again you will see the speed of at which this real-time prediction happens. Okay, there it is. In this case, the mushroom with these parameters is estimated to be poisonous to eat with a score of 66.4%. Now, interesting to know is that Microsoft has a gallery of predefined machine learning APIs that other people have constructed. So you can immediately use some of the APIs like speech APIs or text analytics APIs in your own code. And of course, you can publish your own APIs as well and make them publicly available. To summarize, we can say that the Azure Machine Learning API is much more advanced than the Amazon API, that you get a lot more controls, that there are a lot more models available, and that if you need to do specific manipulations on your data using R scripts, using Python scripts, that you can all do this in real time by creating your own workflow. These are things that the Amazon machine learning interface is certainly lacking. So this really makes it more suitable for these data scientists that wants to have much more control over what is happening in the analysis and in the predictions that are being made. So that's wrapping it up. I hope you enjoyed the screencast and see you next time on our next Cloud Chat. Bye.